portfolio of homes, or from the insurance side, your incoming premiums, you now have this pool of money, and they might go out, and I might have to dump a shit ton of money out into the world, if I have too much property risk. And people are talking about this as systemic risk. Markets won't be able to respond though if they don't have that risk information. Only the big guys really have access to expensive consultants in order to figure this out for them for their portfolio of homes. So what's the answer for the little guy? That's the climate check kind of idea. So trying to get into a space where you are providing easy to understand information is maybe not even is like almost too specific, because you also run this tension of you're talking to non-analytics types. There's a comfort there to having a number that's relative, right? I have a score of 1 to 100, right? That gives me a relative risk on the risk that I'm talking about. So, for an everyday non-analytics type of person, there's a value to having that kind of image. I think it kind of makes it a bit easier. You can kind of see a signal, have an evocative response to what that is, and then move on with your decision making, or you can get more information about what that experience might be. And so we try and surface the data in that way as friendly as possible. And so this is our first iteration. So the example for temperature, would be, this example, you have a temperature risk of 49 out of 100. And I'll describe what that number means, but it just gives you this relative range across the whole US, right? Compared to other places in the US, you're pretty average, right? In terms of your temperature risk. Now, everywhere is gonna get hotter. Most of the time when we talk about temperature, it feels like we talk about, the average temperature, and it seems like such a small change. That doesn't really, move people and get them, I don't want to say I'm trying to be a Pollyanna in front of, real people about climate change, but I want them to feel urgent, right? I want it to feel urgent. And so the other thing that climate change will bring is more extreme events. So we're going to couch it in terms of how your experience with temperature will change in a way that you'll really notice, right? So this isn't a great example because it's, moderate risk or things like that, though everyone's temperatures will increase and you'll have more extreme heat days. But a great example to use would be like Maricopa County, which is what Phoenix is in. You would already expect to have, so in the model for 2020, you're already expecting to have 20 days over 110 degrees. I already can't fathom that as a Pacific Northwest person, what that is, 20 days over 110 degrees. Into the future, that'll increase to twice as many. Right? And that's a lot of time to be spending above 110 degrees. So that'll put, once you get to those kind of extreme temperatures, that's heat stroke for the elderly and those that work outside kind of conditions. So there is, a mortality element to temperature. But some of the risks here that I'm gonna briefly mention are things about catastrophic property damage. For things like temperature, this is also about adding resiliency, right? People already are moving to Phoenix, even though it's 20 days above 110 degrees. Some people like it. It's one of the fastest growing metropolitan areas. It has a lot to do with its affordability and its job growth. So you got to balance, those two things with kind of what we got to do for climate. But it does mean that you're running your air conditioning all the time. It's going to get worse. And so those air conditioning costs are going to increase. What do you do to your property, right? Is it new windows? Is it, there's lots of new technology about new paint that can reflect the light better. So it actually, makes your home cooler, or down to, adding more greenery can lower the temperature as well. That'll be, your water bill will be intense in Phoenix if that's the option you use. So it's also about kind of helping people get ready. It's not just about don't move here because, catastrophic risk, but, how do we just talk about what climate change will feel like in order to get people more willing to take action and do collective changes. So really quick, just talking about our methodology and what we're doing, kind of more across the board here, is that we're trying to present these climate change related hazards. So wildfire, heat, storm in this context does not mean storm surge from hurricanes and the way that we're actually modeling it here. And I think we stopped calling it storm. We started calling it heavy precipitation as heavy precipitation risk. So the idea that if you have a lot of snow at one time, that's roof damage, right? If you have a lot of rain at one time, that's erosion, mudslides, that kind of thing. Flooding is separate, right? So flooding has not just, I think the climate change version of flooding is very provocative. You know, in terms of coastal sea level rise, right? Places that are going to be permanently underwater. But, you know, many beyond that, it's high tides, it's storm surges, right? So sea level is also higher, and now I have more violent storms, so that'll go even further inland. Storms will be more severe. And then inland floods will also be more common because, you know, as everything dries out and the air becomes less humid, it doesn't do a good job at regulating itself, and you get more volatility in precipitation as well. So it's weird, right? It's hard to talk about to lots of normal people. You're going to be more likely to have droughts, but you're also going to be more likely to have storms. So then what does that mean? But trying to present people that information. And Anna, here's I know you can't really tell the resolution, but you can kind of see, you know, drought has much less fine resolution because these are watersheds. Whereas storms, which is precipitation, this is the similar model data set, storms and extreme heat. It's both comes from a similar, you know, modeling of meteorological. Fire is the MC2. Fire is complex, man, because it's temperature, precipitation, soil moisture, and then also the vegetative cycle, right? You know, how do you kind of forecast that out? That's a tough one. This is probably the most stochastic of our risks is fire, and yet it's the kind of one of the most provocative. So it's certainly something to talk about. Here's kind of some of the ways that you can kind of visualize or thinking about the flood that we go through, but let me quickly go to my command center. Okay, so we're in the business of taking data to real people. Now there's the atomistic data. You can type in your address and you see these scores, and you as the consumer now experience this interface, you know, and you get a feeling about a different area. You can compare different properties. Maybe you're not just an everyday consumer, maybe you have a portfolio of homes, you know, you're a mom and pop landlord, you know, that kind of thing. You can experience it that way. But a big push of what we're doing, and what I do in particular, is I'm going to now talk about trends, right? I'm going to talk about what's happening where, and kind of take it back up to a market. I'm an economist, by the way, by trade. I know we did that bio in the beginning. So as an economist by trade, it's, to me, you know, in order to talk about things, it's hard to say, like, you know, that house on Main Street, they have that risk like this, right? Instead, you got to say San Francisco versus Sacramento, right? You know, more inland. Or you talk about, you know, an interior county, you know, King County versus moving out to Snohomish, right? You have to make these more colloquial comparisons to people. So let's go to my command center. I'm going to do the big gnarly command center first. I call my Tableau work my command center because I put a bunch of stuff in it, and then I have it open whenever I talk to media, and I can kind of pull up different ideas in order to talk about them, in order to kind of cast it. So here is, I just talked about Maricopa County, right? So currently 21, sorry, I got it off. It wasn't 20, it was 21 extreme heat days expected, currently over 110 degrees. But later it'll be 46, right? So that idea of like just so many more heat days. And if you look at the heat risk, and here again, okay, and I should define, this is interesting. This is some of the nuance with how you kind of have this conversation and how you present this data.
Are you showing the Tableau?
Oh shoot, is it not? Yes, I was.
Yeah, it's not.
Okay. Stop share screen, Tableau. Okay, so you can see here this was the Maricopa County. I hovered over to give those examples. Notice that I'm in a situation where Maricopa County is so very hot. It's going to get so very hot. I mean, golly, 46 days over 110, but it only has a relative heat score of 71. And a lot of that has to do with the fact that, you know, for people in Phoenix, that's something that they're used to. The infrastructure can support that much air conditioning. It's already had a lot of air conditioning, can support it, right? There are places where they're going to get much hotter, but they start from a lower temperature. So that change in heat is much more significant for them, and that makes them have more extreme heat days. Because one of the ways that we define an extreme heat day is to look at your historic average. So previously, what was a normal temperature for you, and then what do you expect in the future? It's going to stress your infrastructure if that heat increases a lot. You're going to run air conditioning more if you even have it. I don't have air conditioning in the Pacific Northwest, right? So if I get a day at 90 degrees, especially if I get a few days at 90 degrees, I'm feeling it in a way that another 100-degree days in Phoenix, might not really matter. And so, one, trying to put the data in a way that you can understand locally, in a way that will actually impact your life, right? Your lifestyle. That's one of the challenges of like how you model that together. And I should actually mention, in order to take those granular, so I have this raster file, right, down to a certain granularity that's been downscaled, kind of some of the techniques that I like, one of the outputs that Anna's team, people that use Anna's modeling would use, and then they create these more higher resolution. We would ingest that. I have that now at a raster. In order to create these county level numbers, and I have city level numbers, and lots of ways to talk to different people about the ways that the country is different. But what I'm doing is I'm just taking the population within each one of those same grids, a similar raster file, but for population. And then I'm using a population weighted average of those risk scores. So then I can say something like the typical risk in Maricopa County is, and then have that conversation with people. Wildfire gets weird because they always want to know like the total acreage burned in a place, but a lot of the burning gets done far away from residential areas. And so that's actually, it's just a funny way that you talk to the media about things they want to know about, this millions of acres that will burn. And you're like, well, I mean, that matters a lot, right? But if you're kind of thinking from your personal perspective of what, you're going to do, it's more about the likelihood that, it'll burn near you. And so then how do you present those risks? And then talk to the media in a way that seems fair or still the way they want to talk about it. Anyway, I want to give you kind of a little bit more insight into this, like how do we put these things together? I'm giving you the full distribution across these counties, and they've been population weighted. So this actually approximates the distribution of those cells. Because the cells are, whatever it does. And so here we've got these distributions. These are like the cumulative distribution functions. You know what I mean? Like it's the shape of it, right? So seeing like how many properties are above this level, this is what the shape kind of evokes here to look at it all. So you can see what underlies this risk rating. Remember this friendly score, that's someone can kind of see, they can know that what underlies it is extreme heat if they hover over, right? But think of it as kind of like this credit score to give people to kind of have a quick and easy understanding of it. If are people math averse? Is that what I'm saying? If they're analytics skittish, I guess, I don't know, but and then having these colloquial definitions, you can kind of see how they match up, and they don't match up perfectly when I rank by the rating, is because we also want to weight on the change in the increase in extreme heat days, right? This idea that I'm going to penalize you if your heat gets worse, right? Because it's going to stress your infrastructure. So it's not just having extreme days, it's having more extreme days that is going to be what affects people's lifestyles to move forward. Let's see. When did I start, Sophie? What's the timing I have?
Yeah, it's like your session is to 6:10, but we can go a bit longer if you want. Since
okay, sure. I just, when I have this much data, I can talk for a long time. But I do want to just show maybe on this one before I get to wild. Well, let me talk about the storm risk. I want the full distribution, not just trying to find outliers for people, because people media likes outliers. So sometimes it's funny, like when we're modeling, we don't like them, but then they can be pretty provocative and kind of give someone an example. So you can kind of pull them